Good morning, learners. Welcome to our today's lesson. I hope you had a good weekend. So our lesson today is just extension of our previous lesson, what we've been doing. But today we are going to do something different. That is revolution and circumference. So I would like to take you through examples on how to solve questions pertaining revolution and circumference. So we are saying that a revolution, one revolution is equal to the length of the circumference. So if we have a circular, because when you talk of circumference, of course it is something that is circular. So when you talk of revolution, that is one revolution is equal to the circumference of this circular object. And we're also saying that if, for example, a wheel makes a known number of revolutions, we can find the distance it covers by using the formula. So, for example, we have two boys. One boy is standing at middle of the field, and the other boy is standing, let's say, at the goal post. Now, these two boys are playing using a tire, for example. So one pushes the tire as it rolls to the other boy. Of course, we can find the distance between the two boys, of course, without measuring. But what we need to do, of course, we need to get the circumference of the wheel, of that wheel that will be, of course, rotating. Then we also need to get the number of revolutions that this wheel is going to make from this boy to the other boy. That is in the middle of the pitch. So we are saying that now one revolution is equal to the length of the circumference. So we can say complete revolution is equal to the, we are saying it's equal to the length of the circumference. So we are saying that if you have a wheel and you rotate the wheel, or you make the wheel rotate, the number of revolutions, of course, is going to make, for example, from one point to the other point, definitely we are going to calculate the distance from one point to the other using either, we are saying, finding the distance. Now, how do we find the distance? So distance is equal to the circumference. You have circumference, then multiply by revolution. So we are saying for you to get the distance now, for example, between the two boys, you will get the circumference of the wheel, then you multiply by the number of revolutions the wheel is going to make. So example 1, let's have example 1. Examples. Example 1. So example 1, we are saying a bicycle wheel of radius 35 centimeter. A bicycle wheel So a bicycle wheel distance, find the distance it covered in kilometers. Find the distance it covered in kilometers. In kilometers. So the first step, we have this wheel of radius at 5 centimeter. It makes 2000 revolutions. So we want to find the distance it makes when it rotates 2000 revolutions. So I've said that the first step number 1, find the circumference of the wheel. So we are saying circumference is pi d, whereby our pi is 22/7. We have the radius to be cut 5, so the diameter is 70. 7, 1, 7, 10. We have 210. Those are centimeters. Step number 2. Second step. Take circumference. That is the circumference. Then multiply by the number of revolution. So we have circumference multiplied by number of revolution. So we have the circumference to be 220. The number of revolution is 2000. So there we have that is 4, 4. That is 0, 0, 0, 0. That is centimeters. So the question is, find the distance it covers in kilometers. So we need to convert this one into kilometers. So we are going to divide by 100,000. 100,000 centimeter is equivalent to 1 kilometer. So 3 zeros goes with 3 zeros. The 2 zeros, that is 1 zero with that 0. Then the 0, we bring the decimal point there. So definitely, this wheel is going to cover 4.4 kilometers. So when this wheel rotates 2000 revolution, the wheel will cover 4.4 kilometers. Our next example, example 2. So we have seen example 1. So our example 2, the question says, Wanjohi rolled a ring. Let's say, Kamau rolled a ring. Kamau rolled a ring of radius 42. Of radius 42 centimeter, which covered a distance of 396, which covered a distance of 396. This is decameters. This is decameter. This is decameter, dm, capital DM. So the question is, how many revolutions did it make? How many revolutions did it make? So this question, we have the radius of the ring, we have the distance the wheel covered. So we want to find the number of revolutions. So revolutions, we are saying, revolution, it is the distance divided by circumference. We have distance over circumference. So we have the distance, we are going to divide by the circumference. So first of all, we need to find the circumference. So circumference is equal to pi d, which is 22 over 7. Our radius is 42, so which is 84. 84. 717, that is 12. So you have multiply for me, minus 22 multiplied by 12. 22 multiplied by 12. Of course, we have 260. We have 264. 264. So our circumference is 264 centimeters. So our first step, of course, we have now the circumference of this wheel. Then we move on to the next step is now, of course, changing the distance. We have 366 the dm, decameters, of course, into centimeters. And of course, our conversion is 1 decameter is equivalent to 1,000. 1 dm is equivalent to 1,000 centimeter. From your conversion table, of course, learners, use your conversion table so that you understand how many decameters are equivalent to how many centimeters. So we are saying that 1 decameter is equivalent to 1,000 centimeter. And of course, we have 306 decameter. So of course, we have now 396 decameter. So we do some cross multiplication, and of course, we are going to have something to do with 396,000. These are centimeters now. These are now centimeters. Then we are going to take, now this is the distance, of course. We are now going to divide by, the circumference, which is 264 centimeters. Learners, in 5 seconds, I want you to divide this. In 5 seconds, divide this one for me. Definitely, of course, after dividing, you'll have 1,000, that is 500. And this is revolution. These are number of revolutions. These are number of revolutions. So you can see that example 1 is quite different from our example 2. So master everything. Master from the, of course, the first example is more like easy for you. But this time, this is number 2, they have tried now to twist, whereby they are giving you the distance, of course, in terms of decameter. They are testing whether you know the conversion table in terms of measurement. Number 3. Let's look at example 3. I say I'll give you 4 examples before I give you assignment. So our number 3, we have a wheel was rolled 2,000 times. Number 3, a wheel was rolled 2,000 times. A wheel was rolled, we are saying 2,000 times, and covered a distance of 880. 880, these are meters. Find its circumference. The third example is quite now different from the first two examples. So we are saying that a wheel was rolled. So we are rolling this wheel. It rolls 200 times, and the distance this wheel is making, it is 880 meters. Find now the circumference. Now, for us to find the circumference, we are saying circumference. So first step, we are saying we need to find the circumference. And circumference, we are saying the distance over the number of revolution. The distance over the number of revolutions. So we have the distance to be 880, of course, meters. 880 meters. So we are going to take the 880, those are meters. We are going to divide by the number of revolutions, which is 2000, 0 and 0. So we have 88 divided by 200. So learners, within a second, of course, we are going to have 0.44. So we have 0.44. Those are meters. Those are meters. So if I told that the question is talking about find the circumference in terms of centimeters, of course now we will convert this one into centimeters, and of course you will multiply by 100. Of course you will get the circumference. Then our last but not the least, our last example. Our last example is the way coming. So our number four, a cylindrical tin was rolled. They're saying a cylindrical, sorry for, it's supposed to be cylindrical tin, we are saying was rolled 2,500 times on its curved surface on the ground. If it covered 1.65 kilometer, find its radius. Find its radius in centimeter. So now we have a task, of course, to do here. So this is a tin that was rolled. We are saying it is a tin, of course, and it was rolled on its curved surface. So when you talk of a tin, of course, it's something like that. We are saying it is cylindrical. This is the curved surface that we are now referring to. Then we are going to roll that tin as it rolls down. So it makes 2,500. These are times. Then we are saying that as it rolls, this number of times, it is covering 1.65 kilometer. So they want us to find radius. So how do we solve this? Now, solution. So to find the radius of the routine, first we need to find the circumference. And of course, we have said circumference, it is the distance covered. So circumference, it is the distance divided by evolution. Then, so we have the distance is 1.65 kilometers. So we are going to convert this one. So we are going to convert the distance, which is where is our distance? Right, our distance is 1.65. Then multiplied by 100,000, because we are converting these kilometers back to centimeters. Then we divide by the number of revolution, which is 2,500. Of course, 0 and 0, 0 and 0. So definitely, after simplifying, of course, we are going to have 66. When you simplify, we shall have our circumference to be 66 centimeters. But this is not our answer. The question is asking, find the radius. So now for us to find the radius, of course, we are saying circumference is equal to pi by d. Then we are going to take 22/7 times the diameter that we don't know. Then it gives us 66. So meaning that now we are going to take 22 times d, which is equivalent to 22d/7, then is equals to 66. We are going to reciprocate. We are going to use the reciprocal of this. So let's have a good space. So we have 22d/7 is equal to 66. So we are saying that we are going to use a reciprocal of this. So by 7/22 by 7/22. So 22, 1, 22, 1. 7 and 7 goes. You remain with the diameter. We can use 22, 1, 22, 3. 3 times 7, we have 21. So 21 is the diameter of this tin. But of course, the radius we divide by 2, so our radius is 10.5 centimeters. So learners, I hope we have done 4 different examples whereby at least now, at this time, you are at a right, of course, on the right ground. Whichever question that will be, of course, twisted from revolution and circumference, at least by now you are able to attempt and work it out. So to add on this, I'm giving you work so that now you keep on working and of course practicing so that at least you understand this. So our exercise today, revision exercise 4.3. We are saying revision exercise 4.3. That is meter. Then those without the books, I will send the work later so that everybody, of course, should be we should be on the same platform. So thank you for listening, and of course may God bless you.